In this lesson, we want to investigate multiplying by a power of 10. The goals are to evaluate 10 raised to a power, and then also to multiply by a power of 10. Let's first see if we can identify a pattern for powers of 10. Well, 10 to the first would be equal to 10. 10 to the second would be 10 times 10, which equals 100. 10 to the third, we'd multiply 3 factors of 10, which is equal to 1,000. 10 to the fourth would be 4 factors of 10, which is equal to 10,000. And 10 to the fifth would be 5 factors of 10, which is equal to 100,000. If we count the number of zeros here, notice it matches the exponent on 10. So in general, 10 to the power of n in expanded form is 1 followed by n zeros. So if we had 10 to the 8th, this would be 1 followed by 8 zeros, which would be 100 million. Now let's take a look at multiplying by a power of 10. 5 times 10 to the second is the same as 5 times 100, which is equal to 500. 2 times 10 to the third is the same as 2 times 1,000, which equals 2,000. 9 times 10 to the fourth would be 9 times 10,000, or 90,000. Before we discuss the pattern, let's look at two more. 14 times 10 to the second would be 14 times 100, or 1,400, or 1,400. And 273 times 10 to the third would be 273 times 1,000. Notice one shortcut would have been to just add the number of zeros that match the exponent. Here we just added 2 zeros to 5. Here we added 3 zeros to 2. Here we added 4 zeros to 9, and so on. But we also want to develop a pattern that we could use when multiplying a decimal times the power of 10. For example, if we take a closer look at this product here, the decimal point on this 9 would be just to the right, or right here. So if we had 9, and we move the decimal point to the right, the same number of places as the power on 10, so in this case 4 places to the right, we could also determine this product. So if we move this to the right 4 places, 1, 2, 3, 4, and then fill in the missing digits with zeros, notice we'd also have the product of 90,000. So when multiplying by a power of 10 with a whole number exponent, we can just move the decimal point to the right the same number of places as the exponent. Notice for 14 times 10 to the second, if we have 14, the decimal point there, move the decimal point 2 places to the right, we would have 1,400. So let's try a couple of these when multiplying a decimal times a positive power of 10. Here we have 0.5 times 10 to the second, which would be the same as 0.5 times 100. So we could do this the long way, but the shortcut is to take the decimal, 0.5, and then move the decimal point 2 places to the right. 1, 2, and then fill in the missing digits with zeros, and this would give us our product of 50. So for 1.27 times 10 to the third, which would be equivalent to 1.27 times 1,000, we'll take our decimal of 1.27 and move the decimal point 3 places to the right. So starting here, we'll move it 1, 2, 3 places. We're missing one digit here, so we'll add a 0. So this product will be 1,270. Let's take a look at two more of these. Here we have 27.34 times 10 to the fifth, which would be the same as 27.34 times 1 followed by 5 zeros. But to determine this product, we'll take the decimal of 27.34 and move the decimal point 5 places to the right. So 1, 2, 3, 4, 5. We're missing 3 digits, so we'll add 3 zeros. 1, 2, 3. putting in our commas here, we would have 2,734,000. And let's take a look at one last example. 1.275 times 10 to the fourth is equivalent to 1.275 times 1 followed by 4 zeros, or 10,000. So we'll take our decimal of 1.275 and move the decimal point 4 places to the right. So 1, 2, 3, 4. We're missing one digit, so the product would be 12,750. So this is a nice shortcut when multiplying by a positive power of 10 and the exponent is a whole number. I hope you found this helpful.